Hi and welcome back. In this video, we're going to look at creating our first binary tree class. Let's begin by creating a new project that I've created here in my desktop, and then right-clicking, of course, and creating a new Python file. We're going to call this app.py. And I'm also going to create a couple other files, which I'm going to call node.py, and another one which I'm going to call binarytree.py. Okay. So we have three files, app, node, and binary tree. I'm going to keep them open up here, and I'm going to hide the sidebar just so we have a little bit more space. And we're going to begin. Our binary tree is going to have a starting point, which is going to be a node, and then we're going to be able to add new nodes to it. The first thing to do is to create our node class. Our node class is just going to be a simple object that has a value, a left, and a right node. So we're going to say class node, and it's going to have an init method, a value, and it's going to have self.value equal value, self.left equal none, self.right equal none. Okay, so when we create a new node, it's just going to start as nothing, no children essentially, nothing on the left, nothing on the right. And the value is going to be whatever it is that we pass to the init method. Here I'm also going to add a short repr method, just because we're going to be printing things out, and it may be handy to be able to get a nice representation of the value of the node. So this is the repr method. When we print it out, we're going to see node 5, for example. Let's just verify this is all working by writing a short script here in app.py. We're going to say from node, import node, and then we're going to create a new node that I'm going to have the value 5. And then I'm going to create a new node that is going to have the value 9, and I'm going to create a new node that is going to have the value 13. I'm going to assign these to variables. Left equal that, head equal that, and right equal that. And now we're going to do something like head.left equal the left node, head.right equal the right node. And we should be able to do things like print the head left, print the head right. Pretty simple script. Nothing really is going on, except we've created our first sort of binary tree here. We've got our head node, and then we're setting the left and right node. So we are ending up with some sort of triangular tree there. If we run app.py, we see node 9, node 5, node 13 printed out. If you're interested, you know that this is a pre-order traversal of the tree, even though we've not really traversed anything yet. We've just printed a few of the nodes out. But the first thing we've printed is the head node, then we've gone left and printed that node, and then we've gone right and printed that node. So this is an example of a pre-order simple traversal. Okay, we've got this. Now we're going to delete that and start working on our binary tree class. In this video, we're only going to work on adding a new node. We're going to implement what we've already seen in the lecture, and then we're going to add a few more videos to talk about finding nodes and doing the traversal. So we're going to say from node import node, and this is going to be handy in just a moment. And then we're going to create our binary tree class. It's going to have an init method, and that is going to require the starting point. And it's going to be self.head equal head. So this is going to be the sort of root of the binary tree, the head. You'll see it called a root, and you'll see it called a head. Either is fine. Then we're going to work on our add method, which is going to take in a new node, which is also going to be a node. Notice how I'm adding type hinting here, just so that PyCharm can tell us that a node has a value and so forth. And then, once again, we're going to start at the very top of the tree. So we're going to say current node is self.head. Now the current node is pointing to the very top of our tree. We now want to move through the tree until we either add a new node or we reach the bottom of the tree. So while current node, we're going to say if the new node value is equal to the current node value, we've got a problem, because that means we're trying to add a node that already exists in our tree. We've sort of gone through our tree somehow, and we've ended up with two nodes that are equal. So here we're going to raise a value error. I'm going to say a node with that value already exists. Now we're going to work on our elif. If the new node value is less than the current node value, then we are going to go left. So we're going to say if current node dot left. That means there is a node to the left. We'll say current node equal current node dot left. Simple enough. If there is a node to the left of where we currently are, that means that we still have more traveling to do in order to get there. If there is no node, that means that the new node we want to add belongs in its place. So we're going to say current node dot left equal new node. And of course, we then break out of the loop so we don't continue iterating over infinitely, essentially. And then we're going to add an elif. If the new node dot value is greater than the current node value, we do the same. If current node dot right, that means there is a node to the right. We want to go to it. So we're going to say current node equal current node right. Otherwise, we want to put a new node at the right. So we'll say current node right equal new node. And we will break again. Hopefully this makes sense. We've looked at it in the lecture, which is why I'm going quite quickly through it. But essentially all that happens is we have a node which is at the top of the tree, and then we start iterating this loop. At each point, if we encounter that we're adding a node that is already there, we'll exit. Otherwise, if the new node is less than the current node, and this block sort of deals with going left. Otherwise, if the new node is greater than the current node, this code here deals with going right. The left code says, if there is a node there, move there. Otherwise, add it. And the right code does the same thing. If there is a node to the right, move there. Otherwise, add it. Notice that the nodes themselves don't change as you go through this. All you're doing is adding a sort of property here that makes it equal to the new node. So what's happening in the background is the right property becomes the same object that new node is. It's a reference to the same place in memory. We've looked at mutability before. This current node.write is going to be the same entity, the same thing in memory that new node is. So as you run this multiple times, the current node right and left ends up constructing this tree. You don't lose the value of new node when you reach the end of the method, because that value is now pointed at by the property in each node. And of course, the starting point of this chain of properties is the head. If you lose the head, the entire tree just sort of disappears because you've got nothing that allows you to reach any of the nodes. What I mean is, the head points to other nodes. If you somehow lose your reference to the head, you have nothing pointing to the other nodes. You don't have a way of accessing them because there's nowhere in this code that the children are stored. The children are only stored as references in the head. So, nonetheless, just an interesting thing there. Make sure to not set the head to none or anything like that, because then you're going to sort of lose your entire tree. Now that we have this tree here, we could write in our app a short script to add nodes, but we don't really have a way of retrieving nodes. We don't have a way of printing the tree out. So there's not much that we can do there. But let's do it anyway. We'll do from binary tree import binary tree. And we're gonna see tree is a new binary tree, and the head is a new node, which is going to have the value 9. Then we're going to say tree.add a new node with value 5, and tree.add a new node with value 11. What do you think is going to happen when we print tree.head, tree.head.left, and tree.head.right? Which node is going to be the head? Which node is going to be the left? Which node is going to be the right? Let's try it out. Notice how the head is 9, 5 is at the left, and 11 is at the right. So our code has automatically placed the nodes where they belong. Because 5 was added after 9, and you sort of went through this and found out that 5 was indeed less than 9, so we placed it at the left. Okay. In the next video, we're going to look at how we can print out the tree in order. So I'll see you there.